Now that the MPLS network and the internet network are up and running, it's time to actually start focusing on the client networks, and this is where it starts to get really heavy. In this video, we're actually going to be focusing on the layer 2 and LAN side technologies, which is going to include things like first hop redundancy protocols. So get ready to grease up your spanning tree elbows and a little bit of VTP, a little bit of FHRPs. This is going to be fun and advanced. Let's get going with layer 2 tasks. All right, we're jumping back into the swing of things and continuing these lab tasks here. I had so much fun putting these things together. Here's the thing, I put them all, I made these tasks like a long time ago and I kind of forgot what they are. So we're about to have some fun as we jump into layer 2, because this is one where I'm a little bit fuzzier on. And you know what? I should probably go back to CB2 Nuggets and check out that content a little bit more before I try and do these things. And you should too. If this is new to you, if any of these things feel fuzzy, jump over to CB2 Nuggets. There's a link in the description, learn.gg/DataKnox. That's where you'll find the training content there. So shout out to them for providing excellent training so that we could all get ready to do this. All right, we are doing layer 2 tasks in this one. So I'm going to bring up the layer 2 tasks here. And there they are. We got 18 tasks that we need to focus on. Now, what we're looking at here is over here on customer 2, site 4, and customer 1, site 4. We see we've got all of these switches up and running. There's also this one up here that I'm kind of dragging around. Pay attention to that because we're going to need to do a little bit of work there too. So I'm going to bring them up in numerical order, starting with switch 30. We'll bring up secure CRT. Oh, too many switch 30s already. Off to a bad start. There we go. Switch 30. All right. Switch 32. Here, I'm going to do this. We're going to go split screen for a second. And we're going to do split screen over here. And now I'm going to kind of thumb over a little bit. That way we can see what we're working with. Great. This is what's going to work for us here. Switch 33, 34, 35, 36, and then just switch. Doesn't really have a name. Did I actually give this a name? Or is it just, yeah, it's just switch. Okay, cool. All right, so I've got my switches up here on secure CRT. Let's just do some, basic lay of the land stuff here. Take a look at the IP addresses. Switch 32. I always like doing this. I like just seeing like, okay, what are my IP addresses that I'm working with? So switch 30 and switch 32. You can see they've got these uplinks into R11. In fact, I'll turn on R11 just for good measure. These are not switch ports. They are layer 3 interfaces. And then I see I've got a VLAN 21 here. Do I have that? Yeah, I've got this on both sides. So just out of curiosity, let's do a show VLAN brief. And I see Ethernet 01 on this side is already in VLAN 21. So, okay, cool. So now I know what I'm working with here on customer 2, site 4. Let's take a look at switch 33, show IP interface brief. Cool. Pretty much kind of the same thing here. Let's do a show VLAN brief real quick. Okay. Let's do over here, show IP interface brief. Show VLAN brief. Okay. So some things that stood out to me already. These VLANs are down. The interfaces are down. They do have VLANs created, but there's no interfaces within that VLAN. So that's something we're going to take a look at. Show IP interface brief. Cool. And let's check out switch 36. Show IP interface brief. All right. So now that I've kind of got a feel for everything, I kind of see like what I'm working with here, the VLANs that I'm working with, some of the IP addresses. You know what? There's no reason to just beat around the bush. Let's jump right into it. On customer 2, site 4, that's this green site, configure a Cisco proprietary FHRP between the switches. So not really layer 2, but definitely LAN side service, so I get why I put it here. Gateway IP should be 10.1.24.1. So here on switch 30, I see 10.1.24.2, and on switch 32, 10.1.24.3. So this needs to be Cisco proprietary, so it could either be GLBP. Yeah, that's Cisco proprietary, right? I think it is. Anyways, I'm just going to do HSRP to be safe. How about that? So then it says configure, just looking ahead at the steps. Step 2, configure the FHRP so that switch 30 is the primary. Okay, so we're going to be tinkering with a priority. configure the nodes to detect when their upstream connectivity goes down at either layer 2 or layer 3. Okay, so some tricky tracking objects. If switch 30 goes down, switch 32 should take over. If switch 30 recovers, switch 30 should become the primary again. So we got to have some preemption. Then it says configure EIGRP 60 between R11 and these two switches. Ensure that the switches have a default route that is received from R11. Okay, good thing I turned R11 on. And then it shifts up to the other. Okay, so it looks like we're doing some FHRP stuff here. So let's get it started. We're going into interface VLAN 21, standby for HSRP. Let's just put this in group 1. The IP address is 10.1.24.1. Standby 1, preempt, because we wanted preemption, right? Standy. Preempt, okay. Then we have to do the tracker objects. So first we're going to create our first tracker object. What do I want to track? I want to track the IP address first because we're going to check for upstream connectivity. So we're doing IP route. Then it asks for which route, 10.0.244.11, I think is the IP address. And we're looking for reachability, right? Isn't that what it's looking for? Oh, the mask, yeah, 255.255.255.0, then reachability. Okay, so there's my first object that we're tracking. Now it said layer 2 as well. So I'm going to create the second object, track 2, interface. And we're looking for my layer 2 interface at Ethernet 00, then the line protocol. So if the interface goes down, then I know that that interface is dead. So now I've got a way to track my IP reachability upstream as well as just my interface connectivity. So that way we've got that, but we need, so you could either do a standby and specify a track for 1, then another line for track for 2, or I can create a track object that tracks both. So track 3 list, and then it asks, we're going to specify this is a Boolean or. So if either track 1 or track 2 goes down, that's what that will trigger a change. So we got to specify object 1, which is our first track object, object 2. So I back out of it, and it says that my Boolean list is up. I can test this out by going to Ethernet 00, shut it, and I see right here my track state has now triggered to down. So I know that the tracker is going to work. Let's go back into interface VLAN. Was at 21, right? Standby 1, track. Oh, we got to do priority. Priority, because this one had to be the primary. We're going to set it to above the default of 105. And now that this one is definitely priority 1, we're going to specify track object 3, which is my Boolean list, and decrement my priority by 10 in the event that it goes down. That should do the trick here on switch 30. Oh, we also needed to do router EIGRP 60, right? Network 10.0.244.0. Okay, cool. Let's do switch 32. Interface VLAN 21. Standby group 1. IP 10.1.24.1. Standby 1. Preempt. And I'll set up my trackers now. Track 1. IP route 10.0.24.0, 255.255.255.0, and reachability. Cool. First tracker set up. Now tracking interface Ethernet 0, 0. Whoop. Line card protocol. Exit. Set up the third tracker, which is going to be my list Boolean or. Specify object 1, which is my IP connectivity. Specify object 2, which is my interface line protocol. Now back into interface VLAN 21, track, standby track. Track 3, decrement, 10 or something, I don't know. So now if I do show standby, looks good. I've got Everything set up here. Here's my virtual IP address. The active router is 10.1.24.2, which is not me. Its priority was 105. My priority is 100. I definitely have my track state up. Everything is looking, you know, hunky-dory at this point in that regard. Cool. Last thing to do is router EIGRP. What was it? 60? Network 10.0.24.0.255. Okay, and let's jump over to R11 real quick. Configure terminal, router EIGRP 60. Let's bring up that network statement. Oh no, Windows Update, go away. And back off one of these 4s. And now I need to advertise the Chuck. Don't go watch Chuck's video. Actually, I love Chuck. Go watch his stuff, but after you're done watching this first. Ethernet 02. Let's do IP. We got to do a summary address here. EIGRP 60 0000 enter. And this one, next one's going to go on Ethernet 03 and a summary address here. So now if I look at my switches and show IP route, there's my default gateway, looking good. So that means when I fire this Docker container up, if we actually look here under the startup configs, where's Docker, right there, Docker. Yep, so you can see it's already got an IP address and a default gateway set to the HSRP. It also has DNS set to 8888. So as long as traffic would get natted out of R11 into ISP 100, yeah, because ISP 100 doesn't know about the 10.0.24 and the 10.0.244 or the inside interfaces here. So you would NAT it out at R11 towards ISP 100, and then ISP 100 has a default route up to the internet. So that way this Docker container would be able to go NAT it out of R11 into ISP 100, then out to the internet. It's not our objective in this video to configure that, but we have now finished 1 through 6. So looking at 7, now focus on confirm the devices do not have VLAN 10 or 20 configured, but they have IP addresses. So we do have IP addresses, and those VLANs were configured, but they didn't have any interfaces in those VLANs. So I feel like we're going to have to do some trickeration there. All right, step 8. Begin by creating trunk ports between each switch. So we're starting with switch 33. So if I look at switch 33 and switch 35, basically every interface that they have that would be up that's not E00 is going to be a trunk port, because I've got 2 links to 35, 2 links to 36, 2 links to 34. It's kind of around the horn here. So anything that's not E00. So if I do show IP interface brief, it's probably just good enough to just grab them all. Let's do config T, interface range, Ethernet 0, almost did it, 1 through 3, comma, E1/0 through 3. Switch port trunk, encapsulation.1q, switch port mode trunk. Okay. From 34's perspective, we're doing E00 through E12. Interface range E/00, nope, through 3, E1/0 through 2. Switch port trunk encapsulation.1q. I think one of the coolest things about switch port trunk encapsulation.1q is you can just like type the first letter for everything except for like SW, tab, T tab, E tab, D tab. Small thing I learned when I was going through CCNA a long time ago. Oh, look at those. Those interfaces came up. Cool. Switch 35. T. 35. So we're not doing E00 up on 35. E00 was a routed interface towards our TIM. So we're going to say interface range E01 through 3, comma, E10 through 2. And switch port trunk, nope, see? Switch port trunk encapsulation.1q, switch port mode trunk. Cool. And lastly, 36. 36 is everything up to 12. 12 is going out to this router. So that should look like this. Config T, interface range, E00 through 3, E10 through 1, switch port trunk encapsulation.1q, switch port mode trunk. Cool. All right, so the trunk interfaces have been configured. That's done with step 8. Configure VTP version 3, domain name of Cisco, on all devices in the site. Switch 36 should be the primary VTP server. All others are clients. Okay, well, we're on switch 36. So let's say VTP version 3. So it's already in version 3. VTP domain Cisco. Domain name's already set to Cisco, so that's probably how those interfaces already got there. Okay, let's make sure it's the primary. So we have to exit out of configuration mode, and we say, what is it? VTP primary for VLAN. System is becoming the primary server for feature VLAN. Come on. Yep, want to confirm. I already hit enter and it already made the change. Has become the primary server for the VLAN VTP feature. Cool. It said to set all of the rest of these to VTP mode client. Okay, already in client. Exit VTP mode client. Device already. So you know the thing is, I think VTP is not something that you can, if I recall, it's not something that sticks in like the running config. This is actually something that's in the register. So when you configure VTP, even if you don't do copy run start, when you boot it back up, it's got the same VTP configuration. So chances are I went through this at some point, configured VTP, configured version 3, and it just stuck with all these devices. Which is why the VLAN database was still VLAN 10 and 20. See, like, step 10 right here, create VLAN 10 and 20. So there you go. If you're going through this for the first time, you'd follow those steps to be creating these. The big gotcha with VTP for me has always been remembering to do the VTP primary VLAN configuration from privilege mode. That one will get you. All right, configure switch 36's Ethernet 1.2 to be in VLAN 10. Okay, interface Ethernet 1.2. Switch port access VLAN 10. Done. Step 11. Oh, that was step 11. Step 12. Configure multiple spanning tree MST. Switch 36 should be the primary server for the MST domain Cisco MST. Bleh. Okay, so let's start by creating the spanning tree config. Spanning tree MST config gets us into configuration mode. The name, what did it say? Cisco MST. The revision, we have to specify a revision number. This will be revision 1. We have to specify our instances. So let's say instance 1 will contain VLANs 10 and 20. Is that what it say we wanted to do? I'm going to guess that's what we want to do. That'll work. And I don't think there's anything else I need to do in config mode. MST region is not configurable as the system is not the primary server for the MST database. I think this is because we have to set that VTP mode to MST. VTP mode server MST. Okay, let's do VTP primary back in privilege mode MST, becoming the primary server for the feature set MST. So we set the mode to be the server for MST in VTP mode in the configuration mode. Then you have to jump back out into privilege mode, tell it that you're going to become the primary database server for VTP. Now let's jump back into configuration mode. And yeah, I think that's what we needed to do. VTP mode server MST. Actually, we got to go back into the configuration mode and make sure this is all good. So now that it's got the configuration mode, we're going to set the name, the revision, the instances, and now exit. Okay, didn't fuss at me. Okay, cool. Cool. So I'm pretty sure we need to do that configuration on the rest of these devices. So here's what I'm going to do. Paste. Uh-oh. Paste. 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 Set these configurations on the rest of these devices. Oh, there we go. Exit out of that. Exit out of that. And exit out of that. Now, I'm pretty sure VTP carries that configuration for MST, but you know, it doesn't hurt anything to do it like that the way I just did anyways. Now, let's actually bring it into spanning tree mode MST and repeat. Mode MST. Copy. So 33, paste. 34, paste. 35, paste. So everything is now on VTP version 3. Everything is now in spanning tree MST. If I actually do show span MST, I see the MST domain listed here. I've got VLANs 10 and 20 mapped in it. I also see my interfaces and how they're participating in it currently. I also see the root for VLANs 10 and 20. Looks like my root is going to be C2100, which I'm going to bet is switch 33. Do show span MST. Yep, right here. This is the root for MST1. So switch 33, because it has the lowest MAC, is currently operating as the root bridge for VLANs 10 and 20, and instance 1. So let's take a look. What do you know? Step 13, make 36 the root bridge for VLAN 10 and 20 with the minimum priority. Okay, so that's very specific. With the minimum priority. That means don't use that root primary command, because that's not the minimum priority. That's just going to, so it's like that 24,000 number. So I think it's spanning tree MST. No, spanning tree. Yeah, maybe MST, right? Or is it VLAN? 10, 20. Nope, not root. I just got done saying that. Priority. And we're just going to set it to 0. What's the next one say? Make switch 35 the backup root bridge with the default config priority. So this is going to be the backup. Spanning tree, VLAN 10, 20, root, secondary. Okay. So now if I jump over to switch 33 after I give it, a second to rethink and reconverge. Okay, still thinks this guy is the root bridge. Might still be converging, or I need to do this in the MST configuration. This might not be the right place to do it. Do show span MST. Yeah, this dude still does not think he is. In fact, it definitely doesn't have the right priority right there. So let's try some other things. Spanning tree. Could have sworn it was an MST configuration. But it's not. Spanning tree, MST configuration. Spanning tree. Is it instance? No. Is it in the spanning tree configuration for spanning tree MST config? Instance 1, VLAN 10, 20. Nope, that's definitely not it. Okay, so it's not in here. Spanning tree. Where are you at? Where are you at? Really thought it was in the MST section. Oh, right there. MST1, the word. Okay, so paying attention, word, MST instance. There we go. Priority 0. Okay, now back to switch 35. Spanning tree, MST1, root secondary. Okay, okay, all right. Got myself there. And now I see the root is changed over here with the priority of, it actually set it to a priority of 1. Cool, whatever. I knew what I meant. Switch 35, if I do show span MST, I see that the priority here has been changed to 28,673. So definitely less than the default of 32.7. Okay, so that's done with 13 and 14. 15, configure a Cisco proprietary aggregation between switch 33 and switch 36. So looking at it right here, this is switch 33 and switch 36 this way. So let's take a look at switch 33, and I'll do show CDP neighbors. So that way I can actually see switch 36 is going to be on E11 and E12. This said Cisco proprietary, so that to me means PAG-P. So if I do interface range E11 through 2, channel group 1, mode desirable, I'll set this to desirable on this side, and 33, and over on 36, do show CDP neighbors, switch 33, interface range 10 through 1, E10 through 1, channel group 1, mode auto. This will be like the passive side, but I should see them come up in just a second. Let's just let them converge, make sure it looks good. I can also do show ether channel summary. And I see the line protocol is up on those channels. What is capital? I is standalone, and S and D. There we go. There we go. Port channel state up. Now everything is SU. Which is good. That's what we want. We want S and U. That is in use in layer 2. Cool. All right, so 33 36 is done. On to step 16. Configure an open standard aggregation between 35 and 34. Should have seen that one coming on my side. Do show CDP neighbors on switch 34. So I see it's connected to switch 35 on E10 and 11. So I'll say interface range E10 through 1. Channel group 1 mode active, and on 35 do show CDP neighbors. Well, process of elimination says it's the ones that are missing. So that would be 11 and 12. Which side am I looking? 35? Yeah, I'm looking at the diagram. It's 11 and 12. Interface range E1 1 through 2. Channel group 1 mode passive. And we'll give this a second to converge. Same thing, do show ether channel summary. Waiting for that port channel to go into SU. Let's wait, there's the port channel up. There we go. Cool. So we've got the 2 ports that are participating. Port channel is up. Configure switch 34 such that it will traverse the port channel to reach the root bridge. Okay, so port switch 34 is up here, the one in the top right corner. So let's look at how it's behaving right now with do show spanning tree MST. Okay, so it's definitely blocking on the port channel because it sees a directly connected path to the root right here through E02. So what I can do is I can just make the rest of these ports just look nasty so that it only wants to traverse the port channel. So this is E00 through E03. So let's try it. I don't know what I was trying to do here, but I'm going to guess this might work. E00 through 3. Spanning tree cost. What's the max? Let me just copy the max here. Okay. Let's see. Do show spanning tree. There we go. Did the trick. So now I'm forwarding all traffic over the port channel to reach the root. Here we go. And I'm blocking on all other ports. Cool beans. All right. So that should do the trick there. Configure rspan to monitor VLAN 10 traffic should be forwarded to switch, which is this guy out here, and into Wireshark. We can actually turn on Wireshark, verify this is going to work. And you know what? I'm also going to turn on, actually I don't need to turn that on. I'm just going to turn on Wireshark. Okay. So we're going to configure a remote VLAN first of all. It's going to get trunked over to switch. Switch has to have that remote VLAN, and then it needs to send it out to the Wireshark interface here. So this is on switch 34. Let's exit out of interface range. Let's create a VLAN 99. This guy's in configuration, it's in client mode. So let's create a VLAN 99 on switch 36, and it's going to be a remote VLAN, remote span. So switch 36, because it's the VTP master, creates VLAN 99, sets it to be rspan, and switch 34, if I do show VLAN brief, it now sees VLAN 99, and everything is happy there. Cool. So we begin by creating our rspan session. Monitor session 1. Source is VLAN 10. And monitor session 1 destination is remote VLAN 99. So now switch 34 is tracking VLAN 10 traffic and dumping it out to VLAN 99, which we want to be trunked up to our switch here. So if I do show VLAN brief, I see VLAN 99. If I do show run, let's just do section VLAN, see what it's got. Not seeing anything there. I just show run. How about that? Okay, so don't see anything in the VLAN. I'm not going to explore the VLAN database. Let's just do VLAN just for sanity check, just to make sure. Okay, cool. Let's make sure Ethernet 00 is a trunk port. Encapsulation.1Q, switch port mode trunk. So now we should be having VLAN 99 traffic tagged as it comes across. And now at this point, I should be able to begin my monitoring session. So let's do monitor session 1. We're going to choose our source as the remote VLAN 99. And our destination is going to be the interface. Destination interface Ethernet 01. Cool. So to verify this works, we're going to bring up Wireshark. Here we go. And do show IP interface brief. Let's do ping 10.0.10.34. There it is. There is my traffic going from VLAN 10. I see there's VLAN 36 to 34 in the replies here. So there we go. RSpan did the trick. We see the ARPs that took place where it was trying to resolve the MAC addresses. Golden. So there we go. Our layer 2 tasks have now been completed. Again, if there's anything that was fuzzy here, definitely go check out our content on CBT Nuggets. And if you found this content enjoyable, please like, subscribe, comment, and make sure you're following along with the playlist too. All right. Thanks for stopping by, y'all. See you in the next one.